Now let's turn our attention to Java lists. Like an array, a list provides random access to its elements. Also like an array, a list is an object. However, unlike an array, you can add elements to a list. The list will grow and shrink as you add and remove elements. And since it's random access, you can add and remove from the middle of the list. This ability to change size is one of the biggest benefits of lists. A drawback of lists is that, unlike arrays, the elements of lists can only be objects. They cannot be primitive types like ints and booleans. Arrays have special syntax. Lists do not. Lists are part of the Java library. The list type with a capital L is an interface, and it can be implemented in different ways. Java provides two different implementations for lists: array list and linked list. You can even provide your own implementation for the list interface if you're feeling adventurous. Since lists are normal objects, there's really only one way to initialize them: by creating a new list object and assigning it to the list variable. Recall that I said Java provides two different implementations of list interface: array list and linked list. The first bullet shows how you initialize a list using an array list, and the second bullet shows how you initialize a list using a linked list. Let's go over that first bullet in a little more detail. We're declaring the variable XS to be of type list, but we're also giving a type parameter, string, to that list. Now, all this is doing is indicating that we want to create a list of string objects. That's going to help Java guarantee that only string objects will be added or removed from a list. Then we assign a new array list to our list. Why can't we just use new list? Well, it's because list is an interface. An interface only provides method signatures. It tells you what methods it should have, but it leaves it up to another type to implement those methods. In the first bullet, we're using an array list implementation. That's the implementation we're going to talk about today. Next week, we'll look at the linked list implementation of list. One last thing about that first bullet. See the brackets with nothing in them after array list? Those are called diamond notation. And as of Java 1.6, that's the conventional way of creating new objects that take a type parameter. It used to be that you would have to repeat the type string inside the brackets so that Java could confirm that the type inside the brackets on the right-hand side of the assignment was the same as the type in brackets on the left-hand side of the assignment. However, as of 1.6, Java assumes that the programmer is smart enough to know that he or she wants the same type there. So Java infers that the types are the same. Okay, let's look at the third bullet. When programmers discover that the Java arrays class has a toList method, they're usually anxious to use it. Wonderful, they think. Now we can create a list with a few initial values in it, similar to what we can do with arrays. However, if you actually look at what this method does, it's almost always a bad idea to use it. This will create a fixed length list. In other words, you will not be able to add elements to the list, and you will not be able to remove elements from the list. You can, however, access and update elements in the list. But Dr. K, you might say, can't you do that with an array too? If you want a fixed length list, why don't you just use an array? And that is a very good question. And my answer would be yes. In that case, you probably should use an array. And that's why I recommend avoiding this method. To use a list, you have to call methods. Unlike arrays, there's no special syntax. If you want to add an element to the end of the list, you call the add method. If you want to add an element at a particular index in a list, you call the add method with 2 arguments. Note that Java lists, like Java arrays, are indexed starting from 0. So the element at index 4 in this list is the 5th element. Also note that when you're adding an element at index 4, you're saying that you want the element that you're adding to become the element at index 4, and that the original element at index 4 and all the elements that come after that should be moved over to the next indices. So the element that was at index 4 now becomes the element at index 5, and so on. Adding an element to the list increases the size of a list. And the method size is an accessor that can be called to find out the size of a list. The get method returns a reference or a handle to the object at index 4. The remove method removes the element from the list altogether and returns it.